Okay, hi guys. We're working on our 517 assignment. Now this one looks like a U sub. Now you can always try U sub really quick. And U sub, the way I talk about U sub is you pick your sacrifice. And if U is this inside, U is equal to x cubed plus 1. If you take the derivative really quickly, du is equal to 3x squared dx. Do you have a 3x squared here to divide out? If the equation was 3x squared x cubed plus 1 squared dx, yeah, this would have divided out that guy. We would have been, yeah, winners. Great. But as you can see, there is no value of 3x squared or any squared in the front. So this one is actually a problem where we just multiply out. It's simple enough that we can just square it. So if I just square this, it would have been x to the 6 plus 2x cubed plus 1. So again, if I just square this, because I remember how to square things quickly, if it's ax plus b squared, it's a squared x squared plus 2abx plus b squared. Square the front, square the back, and double the middle. That's what the rule is. Okay, square the front, square the back, double the middle. So I just did that. Square the front, square the back, and then double the middle. Now I can take the integral of this now, which is going to be pretty easy. X to the 7 over 7 plus, that's going to be a 4, 2x to the 4 over 4 plus x plus c. Okay, and that becomes a 2. And our answer here looks like it's going to be C here. Oh, sorry, B. I meant C as in letter not. I just called out the wrong letter. Okay, so again, you might see a problem. You're like, oh, what special trick do I have here? And this special trick is just really just multiply it out. Okay, let's look at question number 10. Again, if you guys have questions, please go ahead and type them in the chat. Okay, f is a twice differentiable function, such as the total f at 1 is 2. F at 1 is 2, and then the total dy dx is this. Okay, what is the value of the second derivative at x equals to 1? Okay, so I'm thinking how to get from here to here. So the way I get from there to there is I take the derivative. Now the problem is, as you guys can see, that you could try to take the derivative as we see it, and that's perfectly fine. But I'm going to spin things around. I don't know if this is the way. I'm just going to try it. Okay, so I'm going to go ahead and say dy. Let's see. Oh, sorry. This is we're just going to take the derivative as it is. I'm not spinning. Just take the derivative as it is. If I take the derivative of this again, of y prime, the derivative of y prime is y double prime, right? Now, when I take the derivative, we need to do it implicit. We have to be careful about that y. So the derivative of dy over dx, we take the derivative again. This will give us our d squared y dx squared, okay? So when we take the derivative, it's 3y squared dy over dx plus 0. Okay, did you catch that? Because it's y to the third power, we do the power rule first. That's why the 3 came down, became a 2, leave the inside alone, and then we chain rule it. And the derivative of y is y prime. In this case, y prime is the same as us writing dy dx. So we're left with 3 y squared, and then dy dx. We know what dy dx is, the original problem here. It's y cubed plus 3. We don't need to write the plus 0. They said specifically the point that they want us to plug in is that x equals to 1. They told us over here at 1 is 2, the y is 2. When x is 1, y is 2. So we get our y here is 2 and 2. 3, 2 squared times 3 cubed plus 3 is, that's 4. 3 times 4 is 12. And 3 squared is 9 plus 3 is 12. Whoops. 9 plus 3 is 12. And 12 times 12, 144, which is not an answer here. So what did I mess up? Bring down 3 squared times y cubed plus 3. Oh, y cubed. This is cube. I miswrote it. That's cube, and that's a squared. I used the wrong numbers. I'm sorry. So 2 to 2 is 8. 8 plus 3 is 11. And 11 times 12 is the 132. I think, right? 11 times 12 is 12. 12, which is 132. Yeah, 132. Oops, I just plugged it in wrong. So when I'm asked to take the derivative, I just took the derivative of this. I thought I was going to split it maybe, but that's going backwards. If I'm trying to take the integral and go backwards, we have to separate our variables. But since we're going forward, we just take the derivative. And you can see here, algebraically, the derivative of dy dx is d squared y dx squared. So if I take the derivative of this guy here, we end up with this guy here, we end up with chain rule. Oh, sorry, chain rule, yes, but power rule first. Then remember, take the derivative of y is y prime or dy dx. And lucky for us, they had dy dx, we plug that back in here. Jessica, are you okay with that problem?
Yeah, I just made a couple of stupid mistakes.
Oh, darn it, I hate those. Like me here? Yeah, okay. Stupid is stupid does, Mr. Pro. Okay, so this one here, which of the following could be the slope field for the following differential equation? So the slope field is the slopes. So these are actual slopes. Now, oh darn it, there's actually a bunch of these possibilities, right? Oh. Wait, it won't let me scroll. Okay, we have a couple possibilities here. Okay. Now, if I'm looking at this, if I'm looking at quadrant one, okay, let's look at just quadrant one. We'll take examples of this. In quadrant one, if I stick like positive numbers, let's say 1 and 1, 1 and 1, 1 and 1, right? 1 and 1, you can see it's positive. 1 squared plus 1 is positive. Okay, so we know the slope has to be positive here. We're looking good here. For sure, to see how that's a negative, not this one. Let's look at our other two. Positive, positive, right? We're positive on quadrant one, positive quadrant one. Great. Now let's look at quadrant two. So these are pretty easy for us to just check. In quadrant two, let's pick negative one, negative one, negative one, negative one. Sorry, quadrant two is over here. Negative one, positive one. Negative one, positive one. X is negative one, Y is positive one. So that actually kind of looks like zero-ish. But then let's see what that is. 1 squared is 1 plus 1 is 2. So we should be positive here. And 1 plus 1 doesn't look like, so this doesn't look like a good candidate for me. Let's look at the second one. We said the second one was not going to be it. This one here, 1 and 1 doesn't look like a good candidate, but this D1 looks pretty good. Okay, so far we're looking at 1 and D. That seems like our best choice so far. So it looks like it might be this one, this last one here. Because in quadrant 2, it looks like 0. 1, negative 1 and 1, that looks like 0 to me. We said 2B wasn't an answer. And over here, negative 1 and 1 was going to be 0 also. So that doesn't look like a good choice either. And let's just double check. Let's pick one more quadrant. Let's do negative. Let's do the last one. Let's do negative quadrant 3, negative, negative, right? If I do quadrant 3, here is negative 1, negative 1. And we said x squared plus y. That's going to be negative 1 squared minus, plus negative 1. And that should give us 1 minus 1 is 0, okay? That looks like a 0 to me. Okay. Right, so our answer is D.
So we just choose like coordinates and then plug them in.
That I think is going to be one of our easiest ways of looking at it because every x and y gives us different possibilities. And if you remember us doing slope fields, we just picked x and y's. We just started plugging them in. For us to graph a slope field, if I give you this graph, on the AP exam, on the free response question, they, for instance, will give you this question. They'll give you, let's say 1, 2, 3, 4, 5, 6 options. And then you end up graphing what these graphs look like. This is going to be positive, this is going to be 0, and this is going to be 0 also. Right? So yeah. Because at every point, it's not like we can say this graph x squared plus 1 doesn't look like a circle or anything. It's just a weird graph that we have to figure out. But as you can see, I chose easy points. I chose like quadrant 1 and 1. And that was able to eliminate some of the graphs already. Okay. All right, what other questions can I help you guys out with? Are you guys okay when you see the word tangent now? Like look at the question number 12 that says tangent. Oh, what is the slope of the tangent line of the graph of y is equal to blank? And that looks kind of crazy, right? What's the slope? The slope is just the derivative. So we just take the derivative here. A y prime is y prime. This looks kind of terrible, but it's just quotient rule. So derivative of the top, e to the negative x, negative 1, leave the bottom alone, minus the bottom. Derivative of bottom is just 1, e to negative 1, negative x, all over x plus 1 squared. Okay, they want us to do it at 1, so we plug in 1. Plug in 1, 1, 1, 1. E to the negative x is e to the negative 1 negative times 1 plus 1 is 2 minus e to the negative 1 all over 1 plus 1 is 2. 2 squared is 4. We can factor out the e to the negative 1. Okay, can simplify that way. And this goes to the bottom. So that goes to the bottom. 4e on the bottom and negative 3 on top. Oh, I messed up. Messed up my signs. Where did I mess up my sign at? 1 plus 1 is 2, 2 negative. Where did I mess up my sign? I'm getting negative 3. Oh yeah, never mind. The negative 3 is right here. I just didn't see it. The big deal is just knowing this vocabulary of a slope. Slope of the tangent line is just the derivative. Whatever this graph is, the tangent line has a y is equal to mx plus b. That's our algebra 1 way, or y2 minus, y minus y1 equals m, x minus x1. That's our tangent line equation, line equation. What other questions can I help you guys out with? Tangent line. Even this one looks terrible, right? But it's just the derivative. What is the slope of the tangent line to the curve? Fine. So unfortunately, we have to do this implicitly. The derivative of y is y prime. So you can write y prime instead of dy dx if you would like. That's fine. Derivative of 2 is 0 equals to the derivative of 2x squared is 2x over 2 to the 1 power. Chain rule is just 1 minus 2 sine y. It's the derivative of 2 sine is 2 cosine of y, y prime. Right, the derivative sign is cosine. And now we have to get y prime to one side. So the way we do that is we say y prime plus 2 cosine of y, y prime equals to just x. Then we can factor out the y prime out. 1 plus 2 cosine of y. This is straight algebra 2 stuff. Y is equal to x over 1 plus 2 cosine of y. Okay. At the point 2, 0. So if x is 2, y is 0. What's a cosine of 0? You looking at my unit circle. This is my x is 1, y is 0. So cosine would be 0. The cosine of 0 is positive 1. It's 1. So it'll be 2 over 2 plus 2 times 1, which is, that's a 1. 2 over 3. The only calculus part here was to take the derivative. And everything else was algebra 2. Now you practice that 2, 3 times. The hardest part again is sticking to your guns. The only calculus here is just taking the derivative. The derivative of y is y prime. Now, do you remember to do chain rule here? That's the next thing. Kids always forget the derivative of sine of x is cosine of x, and then x prime, which is just 1. So we don't worry about it. But if I say cosine of y, it's cosine of y, chain rule, and y prime. Oh, so squeaky.